Hi there, welcome to the step 9 of the Mockito course. In the previous step, we learned how to capture an argument which is passed to a method which is called on a mock. In this step, we would learn about Hamcrest matchers. What we'll do during this step is add the Hamcrest matchers library to our POM and get that dependency into our project, and then we would look at how the Hamcrest matchers make writing asserts very easy. You can see these code snippets. You can see that assert that scores has size 4. Assert that scores has items 101, 101. Assert that scores has every item greater than 90. Assert that empty is empty string. So this is much readable than the usual assert equals syntax. Hamcrest matchers bring in this kind of a syntax which makes your test readable. One of the most important things about code is that code should be as much readable as possible. Clarity of code is very important. When I write something, everybody should be able to understand it. And that's what Hamcrest matches would allow us to do. They'll allow us to write asserts in such a way that everybody will be able to understand them, and it will usually result in very maintainable application. Let's get started now. We are in step 9, and what we want to start with is adding the Hamcrest library. So if you look at the group ID, it's org.hamcrest, and the artifact ID is Hamcrest library. We want to use the assert things from the Hamcrest library. So we will add this dependency in. So I'll copy the snippet, the dependency, and add it to my pom.xml. So I'll add it as a new dependency in my pom.xml. I've not yet saved it. You can see the maven dependencies right now for this particular project. There are JUnit, Hamcrest Core, and Mockito all. So I'm going to save it. You'd see that there's a new dependency which is coming in, which is the Hamcrest library. And the Hamcrest library is what we would be using for all the asserts that we write in this particular class. Hamcrest Core only contains the basic stuff. Hamcrest library contains a great deal of asserts which would really help us in writing more readable tests. So that's the library that we have added into the POM, and we see that it's added to our maven dependencies. So we have that available for us to use. So let's go ahead and create our test. I'll go ahead and create something in com in 28 minutes Mockito. So I'll say right click new. I would want to create a test class. So I'll say other. Oh, here is JUnit test case, so I can use that. And I would want to call this Hamcrest matches test. I'll remove this fail as usual, and we can now get started with using a Hamcrest matcher. What I'll create is a simple list. I will hardcode this for now. List of integer scores is equal to, let's say, arrays.asList, and I'll have a few scores added in. I have a list now, arrays with 4 numbers, and let's say this is the output from some program. So I'm writing a unit test, and I see that I call the method that I would need to call the system under test, and scores is the output I got. And now I would want to assert things on the score. Now let's start with asserting. Let's say how many items are there. So I want to assert that scores has 4 items. Let's do that. The method which we'll be using is assert that scores has size of 4. Let's save this, and I'll ask it to add the starting import. So let's save this and run this test. There you go. That's successful. So now I'm able to check that scores has size 4. Let's now have something else. So assert that scores has items. Let's say I want to check whether these items are there in the scores. I'll go ahead and add a static matcher for the matchers. Has items 99, 100. Let's go ahead and run this. You'd see that this would succeed because both items are there. If you add some item in here which is not there, let's say 106, it fails. So it's saying expected a collection containing 99, but a collection containing 106 was not found. So it's saying 106 was not really found. Let's say I want to make sure that every item in this list has some condition. Every item on that list has some specific condition. So let's say I want to make sure that every item in this list is greater than 90. Assert that scores every item is greater than how much? 90. Let's press Control 1, add static imports. Static imports again. I'm using it from matchers all the time because core matchers has only some of the methods, not all the methods. So I'll go ahead and use matchers. So now I can go ahead and run this. So you can see how Hamcrest matches make it very easy for us to write unit tests. So, and it's very readable. So assert that scores every item is greater than 90, or you would have something very similar. So you can say every item is, instead of greater than, I can say less than 190. I'll go ahead and add the matcher for less than and run this. There you go. That's successful as well. What you can see is some of the matchers are present in core matchers as well. That's the one which by default, it's a dependency on Mockito. So you'd get the core matchers by default when you import Mockito. But core matchers does not have all the methods that matchers have. So if you look at things like greater than, less than, these are things which are only present in the matchers. I mean, in the Hamcrest library. These are not really present in Hamcrest core. That's the reason why we imported Hamcrest library. Until now, we looked at how to write a few asserts on the lists. So there's a list of items. I would want to check a few things on that particular list, and this is how you can assert that kind of stuff. Instead of you trying to go into the list and check everything, instead of using assert equals, these methods provide you with a greater flexibility. Let's look at a couple of useful string related asserts. So assert that, let's say you are getting an output from a method call. Let's say that's a string. So if you want to check that it's empty, so you can say is empty, that it's a empty string, and then you can add the static import. So this would help you in asserting that something is empty string, and you can actually also assert if something is empty or null. So you can say if it's null, you can say empty or null string and add the static import for that. So this is trying to make it more readable. So on a string I can check if it's empty string or empty or null string in a easy way. So this typically would be an output from some program you are running, some unit test you are running, and you want to check that it's not empty string. And similar to this, there are utility methods which are present on arrays as well. Let's quickly create an array. So I'm creating an integer max is equal to 1, 2, 3. We'll do two things on this specific array. The first thing what we want to do is we want to assert that this array has a specific size. So the size of this particular array is 3. So I want to assert that, as usual, max array with size. Let's see if there's a method. Yep, there's a method matches.array with size. So array with size. What's the size of the array? So this would allow us to assert that max is an array with specific size. In addition to checking for size, we can also check a few things. So if, let's say, I want to check whether a specific array contains the exact list of values, so I can say array containing, and here I have to give all the items which are present in the array. So I want to make sure that this is an array which contains 1, 2, 3. This would check if this particular thing has these 3 elements. The test would succeed. And going further, the important thing is array containing would expect elements in the order they are in the array. So if, let's say, you don't want to worry about the order, then you can say array containing in any order. So you can say in any order. I don't care about the order, so they can be 2, 1 and 3. So I can actually go ahead and right click run, or alt shift X run as JUnit test, and you'd see that this test would succeed. Okay, so we are looking at different ways of how to assert things using matchers on we started with lists, we looked at strings, arrays, and there are a huge range of methods which are present in matchers. So instead of trying to cover each one of them, I think the best way for you to understand what are the different options that are present in matchers is to open up the matchers class. So what I'm doing is I'm clicking this control click or command click. So press the control button and click this particular class. So it will open up this one. So if it might take a little while for you to be able to see the code sometimes, because Eclipse takes some time to compile this, but once it opens up, you'd be able to see all the Hamcrest matcher methods. So the if you want to see the different methods which are present in here, you can press Control O or Command O, and it would bring up all the methods which are present in here. And there are a variety of matches which are present in here. So the thing is, in matches there are things which say check that this particular list contains everything in this particular list, or it contains any of these particular tests. And as you can see, there are a lot of methods which are present: null value, not null value, and array containing is what we used. Array containing in any order. Array with size is what we used as well. And we looked at like there are things to check if it's empty collection. So it's basically to check whether something is empty, and the order thing that we use. So we checked contains in any order. That's what we made use of. If you are using hash maps, then you have methods like has key, has value, has entry. So there are a variety of methods which are present. So less than is what we made use of. Less than or equal to is another method which is present in here. Equals to ignoring white case. So there you see a lot of methods which are present in matches. You can play around these methods as an exercise after this specific step. There are a lot of variety of matcher methods, and I'm sure this would be really useful in writing really good tests. The idea behind this step was just to give you an introduction at the variety which was possible with matches. Until the next step, bye bye. Welcome back. In this step, we will learn the different annotations which you can use with Mockito to create really readable tests. What we look at is four different annotations mainly. One is at mock, the other one is at inject mocks. We would also look at runners, and also we would look at captor. So what we'll do is we'll try and take one of the tests which we have written earlier, and we'll convert it to use it with mocks. Let's get started. So let's take the to do business IMPL mock test that we have written earlier. You can look at it right now. It's about 153 lines of code. I mean, you can reduce them further a little bit, but it has about 150 lines of code, and it has about 5 different tests. So what we'll do now is we'll try and convert all these tests and see how they would look when we use annotations and when we use auto wiring or inject mocks. It's called with Mockito, when we use inject mocks with Mockito. So let's get started with that. Take this thing, make a copy. So I'll say to do business IMPL mock test. I would really call this now, let's say to do by it's a Mockito, and I would want to use the inject mock. So I'm copying it and calling it to do business IMPL Mockito inject mocks test. So let's go ahead and do that. So right now it's not using the annotations, so it's really a misnomer, but that's okay. That's not a problem. Let's fix that now in this step. One of the important annotations which is present in the Mockito is an annotation called at. At mock is one of the important annotations. I can import, it's part of the org Mockito annotations. So I'll import that. I'll import at mock, and oops, as you can see, it says it's deprecated. So the one which you need to use is not from the mock annotations mock, but directly from the Mockito package. So I'll go ahead and do that. So org Mockito. So this should not give me anything. So yeah, that's good. So it's imported it, but that's not a problem. So let's go ahead and now create a mock. So when I say to do service mock, so I'm going to copy this and put it in here. At mock to do service mock. When I say at mock to do service and create a mock, then what Mockito would do is automatically create a mock of this kind and make it available here. But for Mockito to be able to do that, you need to use a specific kind of a runner. So I would need to change this test to use a specific runner. So I would need to say run with Mockito JUnit runner. So I would need to use the Mockito JUnit runner to run this particular test, because what I want Mockito to do is to mock this specific class. So now what this allows me to do is remove the declaration of to do service mock. So wherever I had the to do service mock, now I can remove that, because now Mockito would take care of injecting it for me. It will create it and it will make it available for me. So let's remove that everywhere we have used it in this class, and let's see if it still continues running successfully. Okay, awesome. So we eliminated 5 lines of code. So earlier we were creating the mock in each of the methods. So what we have done now is we have actually moved the mock creation as an annotation. So what this does, like when as soon as I put a run with Mockito JUnit runner on a specific class, on a specific test class, wherever there is a at mock annotation, Mockito would go ahead and create a mock. So it will use the mock method to create the mock and make it available for us. So that's awesome. So now I'm reducing the number of lines that I have to write already. So that's really good. So that's the at mock annotation. We looked quickly at the at mock annotation and we use the at run with annotation. So now let's move on and use the inject mocks annotation. Where do you use the inject mocks annotation? So if you look at this specific example, what we are doing is we are creating a new instance of to do business IMPL using the to do service mock. So every time we create a to do business IMPL, we want to pass to do service mock as a constructor parameter to it. So we are trying to inject the to do service mock into to do business IMPL. So instead of you having to do it is automatically, Mockito can do that for you. So Mockito can look at all the things that are declared at as inject mock. So if I go ahead and say at inject mocks, let's say I'm saying at inject mocks, and I would say to do business IMPL, to do business IMPL, and I'll use the same name as here. So to do business IMPL. Let's say I'm doing this. So I'm saying at inject mocks to do business IMPL and putting to do business IMPL in here. Then what does Mockito do? Mockito will look at all the things that are present in to do business IMPL. So to do business IMPL, the things which are declared are to do service. So to do service is a variable inside it. So it's a member of that particular to do business service. It's a dependency. So it will look at all the dependencies of to do business IMPL and checks whether any of the mocks matches it. So here I already have a to do service mock which should match because it's a type of to do service interface. It will check whether it would match this. So it would match this. So it will automatically inject that in. So I don't really need to write a line of code like this. So I can remove this line of code. So the important thing for you is to understand what's happening in here. So what the inject mocks is eliminating is writing code like this. So let's say I have 5 different dependencies that are needed to create to do business IMPL. All that I need to do is create at mock for them. So if I want to mock all those dependencies, I have to just create at mock for all of them and then say at inject mocks to do business IMPL. What Mockito would do is, what the Mockito JUnit runner would do would be to create an instance of that and make sure that the appropriate mocks are passed and the values are injected in. So now I can remove this line. Let's see what would happen if this test would still succeed. Awesome. So this test even now continues to be successful. So now what I would do is remove that line of code from every test that's in here. So another line that's not really needed. So the number of lines that we reduce will improve the maintainability of the application further. So now I don't need that too. So now if you look, let's keep running the test again to make sure it's working fine. So it's running fine. So that's very good. So now you would already see that we have reduced this size of this particular class by almost 25 lines. So that's almost 15 to 20% reduction in the number of lines in this specific class. That's good. So now I'm using the annotations to auto-wire stuff together. The cool thing that you would notice now is that the tests become much more readable. So if you look at this, it's just like all that the test is doing is declaring what should be the return value for that specific method, making the invocation and checking the assert. So the tests become much more readable. You can see, the given, when, then kind of a style as well. So you're really focusing on the business logic. You're not really worried about the plumbing, the infrastructure. With annotations, that's what is possible. So you'd really be able to focus on the real code that you would want to really write. The next thing which we want to look at is argument captor. So just like all the things which we looked at earlier, you can also create argument captors using a annotation. So basically I would need to say at. I was trying to say argument captor, but actually I found that the annotation is not argument captor, but just captor. I would want to create an captor, and I would want it to be named as string argument captor. So this would automatically create a captor of this particular type. So I don't really need to now create a argument captor. So I've removed that line from here. So this would automatically create the argument captor for me. So the add captor annotation is useful if you want to create an argument captor. And now I can reuse that across multiple tests. So there you go. This test continues to succeed. So now in this particular step, we looked at using all the different annotations which are important with relation to Mockito. The important thing about Mockito is it makes mocking easy. And the important thing about annotations with Mockito is it makes mocking really, really easy. So when I start using mocks, you would see that all my tests becomes much more readable, much more simpler. It will allow me to focus on the business logic. So all the things like setting up the infrastructure, so creating a to-do business IMPL, making sure that it's injected in with the right mocks, creating a argument captor. All these kind of things are really taken care of for me by the Mockito JUnit runner, and I don't really need to run. I don't really need to worry about them. In my tests, I would really focus on writing the specific test at hand, and that makes tests very simple and easy to read. Until the next step, bye bye. We are making a lot of progress, and we are now at step 11. In the previous step, we looked at all the different Mockito annotations. In this step, we will learn a few things called rules. So what is rules, why is it needed, and what are the rules that are present with Mockito. In the previous step, we added an annotation at run with Mockito JUnit runner. The Mockito JUnit runner would make sure that all the mocks are created and are auto-wired as per the need. So when I put an inject mocks, then this to do business IMPL, all the mocks would be injected into it. So the Mockito JUnit runner would check what are the dependencies of to do business IMPL, and if any of them are available in here, then they would automatically be wired in. So they'll be set appropriately. That's what the JUnit runner is. Let's say I want to use Mockito JUnit runner, and I also want to use Spring framework. So let's say I want to use another runner. Let's say I want to use the Spring JUnit runner. So if I want to use two JUnit runners, that's not really possible. So what JUnit came up with is this concept called rules. Instead of using runners, you would use something called a rule. So the way you can create a rule is by using something called at rule. I'll import this annotation at rule, and I can click this at rule. As you can see, at rule was introduced in JUnit 4.7. So it's kind of a latest addition. So this it's basically an annotation. So what happens when I put an at rule on a test is that similar to a runner, the rule will be run before and after the test. So if let's say I put like the specific rule for the Mockito runner is the Mockito rule. You can find the exact snippet in here, public Mockito rule. It can be Mockito rule, Mockito JUnit.rule. So we use, let's make sure that we are importing this in. So basically, instead of using the runner, you would start using the rule. So now I can remove the runner and run this test. You can see that the rule has to be public. So it's throwing me an error saying this should be public. So let's actually make it public. The most important thing is all the rules should be defined as public because the JUnit framework need to be able to access that to run that. So let's now do that, run as JUnit test. You would see that this would succeed. So the great thing about using rules is the fact that now I can define another rule. So there can only be one runner, but you can have multiple rules. So let's say there's a Spring framework rule, a Spring unit test rule. I can add that in, and that rule would run before and after the test to make sure that the initialization is done properly. So basically, the way you can look at rules is that like with runners, you can only have one runner. So it kind of makes the test very brittle or very dependent on a specific runner. And whenever you want to do something else, then you are really tied up because you cannot use another runner. So instead of using a runner, you can use multiple rules. And these rules can do the setup for you. So JUnit is now moving away from runners and moving more towards rules, because rules makes the test more flexible. You can have multiple rules defined and each one independent of each other. So there you go. That's a really short video to discuss a little bit about rules. So you'd see a lot more people using rules going forward than runners. Until the next step, bye bye. Welcome to step 12, where we are really looking at a real world example with Mockito. We are going to look at an example project where we use the Spring framework. We would have a business layer, a data layer, and different kinds of Maven projects. And we would try and set this example up and see all the code that's written in here. As far as the Mockito is concerned, then you would see that the tests that we write in this project are not any different from the tests that we wrote in the earlier steps. This step is just to give you an overview and give you a feel of how real world tests, even in complex environments, can be really simple when you use Mockito along with Spring. Let's get started. If you look at our GitHub repository Mockito tutorial for beginners, there's a zip file which is present down here. So it's called Mockito real world example with Spring. So what we would do is actually import this project as a Maven project. So we would go to Eclipse, import this as a Maven project, and then we would try and see what code is in there. First thing we would do is download it. So take your favorite downloader. It's not a big file as such, so you can download it in a few seconds, less than that I would say. So I'll go ahead and say right click, save link as, and or download, whichever you would want to. What I've done is I've extracted the zip file and I've put it in the folder Mockito real world example with Spring. You'd see these folders directly here: business, data, modal, and pom.xml. What we have done is basically we took the zip which was there. So we took the zip from Mockito tutorial for beginners real world example. I just clicked on it, took the zip, extracted it to this particular folder. So you'd see this is the content of that particular zip file. So you'd have a pom.xml and you'd have a business, data, modal, and everything kind of stuff. I would want to import this project into my workspace. The way you can import a Maven project into your workspace is by saying file, import, type in Maven. So type in Maven, and I would want to actually import a existing Maven project. So I would say existing Maven project and say next. I will want to use a different folder, so I know where it is. So I would want to actually browse to that folder. This is the folder where I extracted it to. You can see it's done just now. So I would go ahead and open that, and you'd see a set of Maven projects. You don't really need to worry about all of them, and just go ahead and click finish. You'd see a lot of projects imported in, so you can see a lot of layers, a lot of things that is imported in here. You don't really need to understand every bit of it. I mean, it's just to show a really real world project where you have a multiple sub projects and things like that. Before we start with any of this, we'll try and get an overview of this particular project. This sample project has a business layer and a data layer. And in the business layer, we have an API and IMPL. And the same in the case of a data layer, API and IMPL. If you understand the concept of interface and implementation, then API contains all interfaces and IMPL contains all the implementations of those interfaces. So, for example, similar with data, API contains the interfaces and IMPL contains the implementations. Typically, in a multi-layered application, your business layer depends on your data layer. So the data layer gets the data from the database, and the business layer kinds of has the business logic. So over here, if you look at it, we have the data layer consisting of two APIs. So one is the product DO and the other one is client DO. So product data object and client data object. You can think that these two would talk to the database or talk to an interface, get the details, and the client BOIMPL depends on these to calculate the client product sum. Let's say there is a client for whom there are different kind of products. You can kind of picture this in any kind of business environment. So you have a client, the client has a number of products. So the client BOIMPL talks to the product DO and the client DO, and it would get all the details and then calculate the client product sum and return it back. So what we want to do is we are writing the tests for this particular method. So the things which we would want to mock are the dependencies. The dependencies are product DO and the client DO. So if you look at it from the Mockito perspective, then product DO and client DO, I would like to mock them so that I'll be able to test the client BO IMPL. So I would want to test the client BO IMPL, mocking product DO and the client DO. So if that was confusing, not a problem. Take some time and look at the code inside your Eclipse right now. So let's do that right now. If you look at the data API, there is a client DO and a product DO. Let's directly go to the business API. The business API, the methods that we would want to test are there are three methods. Get client product sum, save changed products, and calculate and save client product sum. So those are the three methods that we would want to test. And if you look at the implementations of them, they are present in the business IMPL. So source main Java, and the business IMPL has the client BO IMPL.java. I'll open this up. It's client BO IMPL. As we said, the dependencies for it are product DO and the client DO. Since it's using the Spring project, you would say at AutoWired, this is an at service. If the Spring annotations do not make sense to you, then I would recommend to go through our Spring course. It's a free course and you should be able to understand Spring completely through that. But if you do not have the time to go through the entire Spring course, you can kind of think of AutoWired as a way I am saying the client BIMPL is dependent on the product DO. And I'm not really doing a new product DO here. So what happens is Spring would create the new product DO, IMPL, and it would inject it in. So the dependencies are automatically managed by the dependency management framework, which is Spring, and they would be injected in here. So we have three methods in here. One of the methods, first methods, if you look at it, is get client products sum. So the first method, what it does is it uses the product DO, it sends a client ID, gets all the products, and it actually sums them up. So it calculates the client product sum. That basically, if you look at it, it just takes all the products and sums them up. So this is like a typical business method in any real world project. So when you are in this kind of situation, you would see that the way we write unit tests for it. So the test, if you remember, it's the same package. So you can see that over here. So it's the same package as the main thing, and you'd see that we are using Mockito to write the test. So the first line, we use our Mockito runner. So we need to be able to run this particular thing. We are using a runner here. One of the exercises that you can do is to convert this to use a rule. So this is using Mockito runner, so you can try and change it to Mockito rule and see if there is any difference. What you can see here is we are declaring the mocks. We want to test the client BO IMPL, and if you look at the client BO IMPL, the dependencies are product DO and client DO. So what we are saying is at mock product DO and at mock client DO. So we are creating mocks for product DO and the client DO, and we are doing an inject mocks into the client BO IMPL. So what would happen is the client BO IMPL would be created and these two mocks would be injected in. So that's basically what we are doing. And if you look at the test for test product sum, what we are doing is we are creating a set of products. We are looking at creating a couple of products, and we are stubbing the product DO get all products because that's the method which is used in this thing. So it's using get all products. So what we are doing is we are stubbing it to return the list of products that we have. So one product has amount 5, the other product has amount 6. So once the method is called, what we are checking is we are checking whether client bo dot get product sum. I can refactor this a little bit to make it even clear. So we have client product sum coming as an output from there. So I'm checking whether the client product sum has a currency value of 11. So that's the test we are writing. It's a very simple Mockito test. But if you look at the entire project, it's a very complex kind of a project. There are multiple layers. It's completely managed by Spring. There are Spring configuration files and things like that. But at the end, when I write the test, it's no different from writing any other test. That's the beauty of unit testing, right? So in such a big system, I'm able to isolate the functionality. So client product sum, I'm checking whether it's really working fine. So I wrote a test with the mocks to return a specific set of products, and I'm checking whether that product sum matches. So with this kind of a test, I'm sure that the get client product sum is properly written. The next method that we have in client BOIMPL is save changed products. So basically you can kind of think of a specific client has a list of products, they are editing it on the UI, and they are sending the final list of products here. And what we do in this method is compare the values which are coming from the screen. So the values which are coming from the screen, that's basically the user entered products, are compared with the database products. So we talk to the database, get all the products, we check whether the user entered products match the database products, and if there are specific products that needs to be updated, they would be updated. If there are new products, then they would be inserted, and if they are old products, they would be deleted. So if user entered, like from the screen I only get 5 products, and let's say there are 10 products in the database, then the 5 at least have to be deleted. So those ones are stale products, so those are deleted. So you can spend some time looking at this specific method logic, how it does it. It's a very simple implementation. You can spend some time with it. The idea is to just show you quickly that the Mockito test would not be any different, even in complex kind of scenarios. So this is kind of a complex kind of a scenario. If you see the test that we are writing for that particular method, this one says save changed products, product in screen, not in database, that product is inserted. So we are testing the save product method, save changed products method. And what we are checking here is the product is in screen, but not in database. We are taking a product which is in screen. So user entered it. So user entered a new product that's in the screen, but it's not in the database. So that's basically a new product that the user is entering. So it's not in the database, but user is entering right now on the screen. Then product should be inserted, because that product, the insert method should be called. So what we are doing is that here. So screen products, we are just creating a sample product, and empty database products because we don't want anything in the product. And then I'm actually stubbing the get all products to return the empty database products. And I'm calling the save changed products method with the screen products. I'm doing this stuff, and you can see that I'm checking, I'm verifying. So this is an example for the verify method. So I'm verifying that insert product is called with the product that is. So this product has to be inserted. I should not call delete product or update product. On this specific product, I should call the insert product method. Similarly, you would see that there are other test cases. So save change products, product in both screen and database. Then what should be happening? Then it should be updated with the new details. So we are creating a screen product, a database products, and we are seeing the screen, like we are stubbing the thing usually, and then we are calling the save change products, and we are seeing that the update product is called on a specific thing. And the next test scenario is product is in database but not on the screen. So you'd see that here delete product has to be called, because the product is there in the database, but this user like from the data we got from the screen, it's not there. So it basically means that user wanted to delete it. So when the method comes in, we would want to delete that particular product. So we are checking that the delete product method is called. So similar to this, we have another complex test that we have where we are using a argument matcher. So we use the argument matcher to catch the client product sum which is saved to the database. So if you look at the client BO method, this one does not only calculates the client product sum but also saves it to the database. So you can look at this test as well. One of the important things about this particular step is that our objective was not to really get you to understand everything in here. I mean, that's like there's a lot of business logic in here. You need to understand client BO, product DO, client DO, a lot of business logic that you would need to understand. But the most important thing that we wanted to show through this example was even in real world projects, how you write the Mockito unit test will not be different at all. We would still be using either a Mockito rule or a Mockito runner. We would use at mock annotation, at mock inject mocks, at capture to capture the arguments. So this is exactly a very complex test in a business scenario, and you can see that the kind of constructs that we are using for Mockito are exactly the same. One of the good things that you can actually try and look at this test and try and replicate in your projects is how the test is organized, how the methods are named. You can also see that there are certain conventions which are used to make the test very readable. So you can try and spend some time on this real world project and try and get whatever you want to get out of it. So the attempt was not to get you to understand everything in here. I mean, that's practically like this is almost like a new project you would be working on. So that will generally not be successful. So the idea was not to really get you to understand every business logic which is in here, but the idea is to show that the test with Mockito can be written in a very simple way, irrespective of how complex your project is. Hopefully, you had a good time understanding this. If there are specific parts that you did not understand, that's okay. The most important thing that we want to understand is the concepts of Mockito. Until next step, bye bye. Let's start with the next step, step 13. And in this step, we would learn about a spy. What is a spy? How do you create a spy with Mockito? And how can you override specific methods in a spy? Those are the topics that we would discuss during this step. Let's start with creating a very simple test. So I'll start with new JUnit test case. I'll go with the package com dot in 28 minutes dot Mockito, and let's call this a spy test. So I just create a quick test, and quickly I'll create a mock for, I'm saying mock of array list dot class. So I would want to create a mock for an array list class. So I quickly created this line, list array list mock is equal to mock of array list dot class. What we have created here is a simple mock. So by default, mocks return default values. So mocks, when I call some method on this, they return default values because I did not tell it to do anything. So if I stub it, then it will return whatever I have stubbed. So let's say if I do stub array list mock dot to return, sorry, I have to take a method. So let's say array list dot size, I would want to return a value of. So what would happen? So if before stubbing, if I made a call assert, at this point it would still continue to return the default value. So mock dot size, because that's the default. But if I do the assert here, what would be coming up? 5. Aha, I should actually revert. Assert equals usually uses expected, comma, actually we got it right. So assert equals 0 comma array list dot size, and assert equal 5 comma array list mock dot size. Let's run this test. This should succeed. So you'd see that succeeds because here it is returning the default value. Now I'm going and stubbing it to return a 5. So when I call array list mock dot size here, it would start returning a value 5. Even if I insert a few values in between, let's say I inserted a few values into the array list. Actually, I'm inserting into the mock. So I'm saying array list dot add dummy. I'm just putting some dummy value in. Will it really cause any change to the size of the array? Let's say even after the size, I'm doing this. So I'm moving this line of code down here. Do you think this would really cause any change in the size of the array? It would not, because all that we are doing is we are not really talking to the real array list class. We are not really adding a value into the real array list class at all. So that's basically a mock. A mock is basically a dummy implementation. So you would get a default value, or if you use the stub or any of the other BDD style methods, you can say when this method is called, return this. That's it. There will not be any logic from the array list class which will be used. So if I'm doing an add, it's a dummy add. It does not really affect the size of the array list or any of that kind of stuff. But let's say I would want to really use the array list class, but I would want to also track whether certain methods are called. So I would want to actually use the ArrayList class, but I would want to override a certain things in the ArrayList class. So when I'm using a mock, typically what we are saying is I don't care what the ArrayList class does. I mean, I don't read any of the implementation which is present in the ArrayList class. But let's say there's a scenario where I would want to retain all the functionality of ArrayList class, but override a specific functionality in the class. So in those kind of situations, we go for something called a spy. So instead of mock, I can say a spy. So if I change it to a spy, then I'm really creating a spy. So let's rename this. So I'll say ArrayList spy because that's ArrayList from now on. The thing is with ArrayList spy, it's like creating a real array list. So it's almost like saying new array list and creating a new array list there. But you can you can stub certain methods if you'd really want to. So because this is creating a new array list, the size of the new array list is always 0. But what would happen if I add a element to the array list? What would happen is it's a real array list. So what would happen is its size would increase. So let's say asset equals 1 comma array list spy dot size. Now I run this, you'd see that the test would succeed. Now you can also go ahead and remove this. I'll say array list dot remove dummy. What would happen? The size of the array list will become 0. I can go ahead and do this now. Okay, there you see. So the test succeeds. So this is a real array list that you are using. But the great thing about the spy is that you can override specific methods. So let's just say on the ArrayList class at the start, stub ArrayList spy dot to return. I have to specify the method which has to return 5. So ArrayList dot size. So what would happen is that the rest of the functionality in ArrayList would remain the same. However, the size method will start returning whatever you are stubbing. So you can see assert equals 5 comma ArrayList dot size. So now you would see that the test would succeed because now we are actually stubbing this. So what would happen when I do this is all the other methods in ArrayList will remain the default functionality which is there in the ArrayList. However, only the size method I'm overriding it. I mean, I'm stubbing it to return a value 5. So this is almost like partial implementation of the array list. So I'm kind of having a specific implementation of the array list where just the size method alone, I'm saying return 5. All the other functionality will still continue working on the array list as normal. So the other benefit of using a spy is the fact that you can also verify the invocation of a certain method. So let's just say I want to insert a thing. So array list spy dot, let's say I'm actually adding an object dummy, and you can verify that on the array list spy dot I can check whether a specific method is called. I can also check what is not called. So add method is called, so verify array list spy comma never, not even once the remove method is called. So when I call the add, I want to make sure that the, let's say, clear method is called. This checks whether the dummy, whether the method call with dummy is made. This checks that the clear method is never called. So let's quickly do that. The test succeeds. So the thing about spy is you can really, it's like a spy. So you let the real action happen, but you are actually listening on to it. So it's like a spy watching what's happening. So let's say like you would have seen a lot of Bond movies, right? Spying and stuff. So what would happen? They would really let the real action continue to happen, except for the places where they want to change the behavior. So that's exactly what you can do with spies here as well. So you'll really let the real behavior of the class continue, but you can watch on it. So here I'm letting the real behavior of array list continue. So array list.spy, I'm adding a dummy value, so it's really added into the array list. But what I'm doing is I can check, okay, has this really happened? Yes. Has this not happened at all? So clear method was never called? Yeah, I can check that. So the spies allow you to keep track of what's happening with the real object, as well as they allow you to override a specific behavior. So if you want to stub a specific method in the spy, you can go ahead and do that. You can change the behavior of the actual class a little bit, as well as keeping track of the real thing on the class. Um, to be really frank, I don't really want to use spies in any of my real world projects. Most of the projects, if they are properly built, they would never have the reason to use a spy. Spy is more in case of, let's say, an legacy system where you don't really have the access to the code of the dependency. So you would want to actually track what's happening on the dependency. So in those kind of situations, you can go with a spy. But in general, I would stick to mocks and I would try and use mocks as much as possible. Because with spies, you are using a little bit of the actual functionality and little bit of the stubbed functionality. And that makes it complex to maintain. So if you take this array list class, if I am actually stubbing a specific method and actually using the real logic in certain other parts, then it really makes it confusing. So I really prefer to avoid spies. It's good to know that there is a concept called spy where when in an abnormal scenario I can make use of these spies, but in 99% of the normal scenarios I would stick with using mocks. Until next step, let's take a break from all the hands-on stuff we are doing, and this would really be a theory step. So what we learned during this step is why does Mockito not allow stubbing final and private methods? We will actually go to the Mockito site and see why they don't allow it. So just go to the link down here and you would see that Mockito doesn't mock private methods. You can read this stuff down here, but the summary is basically Mockito wants to promote good design and good testing concept. One of the things about unit testing is we are supposed to test the public interfaces of a class. Mockito wants to really promote that. That's the reason why Mockito does not allow mocking private methods. Let's go to the FAQ and read a little bit more. So there's a FAQ for Mockito. You can find the link in here. So here you'd actually kind of look through all the decisions that the Mockito framework creators made when they started creating Mockito. So they had to make a lot of choices and they chose a few things. One of the important things is you cannot mock final classes, you cannot mock static methods. Uh, these are all there because of reasons. So typically having static methods is considered to be a bad object oriented design, and you wouldn't want to you wouldn't want to mock a static method in a really well designed uh, program. So that's the reason why Mockito does not support these. There are other frameworks like PowerMock. When used with Mockito, you can override, you can mock final class, you can mock static methods. But Mockito by itself does not support like mocking final and static classes. And with Mockito, as we already saw, we can mock both classes and interfaces. We looked at what are the values which mocks written by default, so you can see that. So you cannot mock static methods, you cannot mock private methods. uh, I, I doubt if you would be caring about whether it's thread safe or not, but just go through this list down here. This is a really good set of things that you can look through to understand Mockito further. uh, the other thing I would really recommend you to do is with Mockito is to always know the other frameworks which are in the specific field. So if you look at Mockito, the real like one of the first mocking frameworks which was really famous was Easy Mock. So you can try and understand the comparison between Mockito and EasyMock. There is a really good page. Typically I would never refer to the create, like Mockito is a competitor to EasyMock, and I would really never want to go to a Mockito page and see the comparison versus EasyMock, because the comparisons will always be in the favor of Mockito framework. But having said that, I think this is a really a fair comparison. I've worked with both EasyMock and Mockito, and I think Mockito is really better framework in terms of readability of code. On this page you can see how things can be written with EasyMock and how it's different from Mockito, and how you can also see that writing EasyMock test is a little bit more complex than writing a Mockito test. So you can see a little bit of more information down here on what is the difference between Mockito and EasyMock to understand Mockito much further. The idea behind this step was to just give you references to where you can go and try and find more information about Mockito. We understood the basic, most frequently used features of Mockito, but it might be good for you to understand what the Mockito framework creators were thinking when they created the framework. So all the things that we discussed during this step will help you to do that. It's not, if you're a beginner, what like it's not really necessary for you to understand whatever we are talking completely. But if you are interested with Mockito, then you can actually go and read everything that's there in the links that we referred to through this step.